Hello everyone, my name is Andres Romero and I'm going to present our work Zero-Pair Image-to-Image Translation using domain conditional normalization. This work was developed with Samar Shukla, Luv Van Gol, and Radu Timofte. We address the problem of zero-pair image-to-image translation, where we aim at performing transformation between two different domains that have never seen each other during training. Let's take for instance the three images depicted here. We have three domains with depth, RGB, and semantic information. During training, we assume we have access to RGB semantics pair and RGB depth pair. And during inference, we would like to go from semantics to depth, or vice versa. This is of course trivial if we consider a simple cascade approach, that is, going from green domain to the orange domain through the blue domain. However, this approach is suboptimal and doesn't work well in practice. Another approach is the proposed in mix and match, where each domain has independent encoders and independent decoders. So we end up with n encoders and n decoders, being n the number of domains. This method produces good image quality, but that does not generalize well due to number of domains. Finally, as each domain shares the same underlying structural information about a scene, the ideal case is to have a common encoder for all domains and conditional decoders for each. And that is exactly what we propose. We believe that using a single network might better exploit the structural similarity between the different domains. In detail, we use a unified encoder to map the information to a latent representation that is consequently decoded to a desired domain using a unified decoder with conditional normalization. We proposed two variants for these tags. The first one, DCN0, impose a domain invariant latent space by computing an adversarial classifier with gradient reversal layers, and the decoder is conditioned on the target domain information through batch normalization. In contrast, or another approach, DCN does not enforce a domain invariance latent representation, yet it uses the domain information of both source and target in order to fit the conditional batch normalization of the decoder. And additionally, it uses a common encoder for all domains. We validate our framework in cityscapes as CNET RGB datasets, and evaluate it using the intersection over union and pixel accuracy with respect to the ground truth semantic labels. For cityscapes, we show the intersection over union for each class and compare against CycleGAN, Pix2Pix, and the state-of-the-art Mix and Match Net, MMNet. Our method performs MMNet in every category, and as an upper bound, we also show Pix2Pix results using full supervision, that is, using all the pair data available. The evaluation study shows the contribution of each part of our two proposed methods. And finally, our method produces better and more fine-grained details than prior works, as you can see in this picture. Thank you very much for your attention. For more details, please check out our poster and our code.